Hello everyone, a very warm welcome to you all. Today, in this video, we'll be looking at units and global variables in Solidity. Alright, so let's get started. Units in Solidity can be classified into two, common units and also time units. Common units can also represent currency, in this case, Ether, right? So the way we represent Ether in our smart contract is very easy. So for the sake of representing Ether in our smart contract, we have various subdenominations, right? And the first, which is Wave, is the smallest subdenomination of Ether. Ether is the native cryptocurrency of the Ethereum blockchain and is used for paying for gas fees, right? So one way equals one, and another commonly used subdenomination is Gray, right? Which is represented as 1E9, and that is 1 times 10 raised to power 9, or 1 with 9 zeros, basically. And to represent Ether itself, right, the unit of Ether, this means that this is 1E18, which means 1 times 10 raised to power 18, or 1 with 18 zeros. Moving forward, we have time units, right? So just like in our day-to-day life, right, 1 second is 1 minute is 50 seconds, 1 hour is 60 minutes, and so on and so forth. Okay, so moving forward, we have global variables, right? So what are global variables? Global variables are special variables and functions that can be used globally in your smart contract, right? So this type of variable give information regarding the blockchain or transaction. This type of variable are accessible anywhere in the contract, whether inside or they are declared outside of the contract. Now, unlike local variables and global variables, which have been declared specifically, global variables are not declared, but rather they are keywords that are by default provided in Solidity. All you have to do is just to use the keyword. Now let's take a look at some of the global variables that we have. We have block hash. This is a function actually, and it takes in block number and it returns the hash of the given block when the block number is one of the 256 most recent block. Now, if it exceeds the most recent block in 256 order, it returns 0. Now, we have others, we have base fee, chain ID, Coinbase. So they practically do their own unique things. Take for instance, block.chain ID returns the current chain ID. For different blockchains, they have their own chain ID. We have block.number, it returns the current block number. We have block.timestamp. You see this a lot. It returns the current block timestamp as seconds since Unix epoch. So Unix epoch is basically the number of seconds that has elapsed since January 1, 1970. Right, we have gas length, msg.data, msg.sender, msg.sig, msg.value. So what this global variable helps us do, take for instance msg.sender, it returns the sender of the message, right, in current call. So msg.value basically is the number of ways sent with the message. We also have CX of gas price, CX of origin. Alright, so this for CX of origin, this is the sender of the transaction when it comes to like the full chain code. Okay, so having said that, you get to use a lot of this while writing the smart contract. Alright, so let's take a look at this contract. It houses various global variables that we already talked about. So let's quickly deploy this. Um, so let's click on each of these variables. Block gas limit. This is the block gas limit. And block number. This is the block number. Ether in wave. We have this value. We mentioned that ethers is 1E18, which is 1 times 10 to the power 18, and 1 with 18 zeros. So if you count this, it's going to be 18 zeros. So let's also check owner. Owner is the message of sender, the person that called, or that sent the message. In this case, it is this address. Right? We also have timestamp. So this return the block.timestamp, as that's when this function was called. Alright, so pretty much it. That's all I want to show for this video. Thank you for watching and see you in the next video.